Recently in Visakhapatnam. So this is the world's highest 3D printed structure till date. This is another structure we did for defense. You can see the entire this thing. Garage was printed in a single way. So these are also the structures that can be done using this. This is at Pune airport. So we also did this structure last year. And we are also
did it there itself or you?
No. We actually printed all these structures here in India.
Here and then ported it.
So logistics are actually costlier, but we did because these were smaller projects. So once we are getting bigger projects, yes, we will be actually shifting this entire assembly at the site itself. So these are some of the projects we did in hill areas as well. These are the accommodation for like 64 men living as well in like very high altitude areas. These are the bunkers. So these bunkers which are being printed would look like this. So at high altitude areas, like these are 28,000 at Leh Ladakh region. Similarly. So basically, in buildings, what we do when we are making buildings, we are making these kind of panels. These are basically self-stabilizing, and then we can pour in the concrete. And what we are doing is we are actually saving the material here by creating cavities. So there the concrete is poured to make column. Rest is actually hollow. So we actually are saving a lot of material, and we are actually making it thermally comfortable as well in the long run. So that's how this is beneficial and why people are actually looking for it. It can be connected to the foundations as well. So this is how the joint detailing can be done. So this is how we are primarily working.
What about material? There's a lot of new material that is coming out from IISc research and all.
Yeah.
For areas like this, right, with very high temperature and dry weather,
Yeah.
they have come up with a material that keeps it cool.
Phase change. Because phase change material.
Yeah, like that.
There are some multiple kind of material like phase change material. There are perlite based
You
material.
can also create 3D walls based on that.
Yes, we can. So basically we have worked with perlite based material. That is one type of material. GIB walls that is called. Plus the advantage of this is that we are creating cavities. So that cavity, air cavity is kind of an insulator itself. So air is one of the best insulators that we have. So once we are able to create cavities in the wall system itself, so it would automatically have a thermal insulation effect in the entire building. Plus, yes, we can use those materials like perlite or other phase changing
Your concrete is
materials.
basically in liquid stage, and
Yeah, when it is being poured, yes.
so
It then sets.
you can add anything in it to make it further functionalized kind
Yeah,
of thing.
generally, yeah, those are called additives. As you have worked in 3M and other companies, yes.
So
those
this
can
is
be-
something important.
Yeah, those can be added.
So then it can be easily
So, sir, with me, like Ankita and Rishabh Gandhi. So, sir, Ankita and Rishabh, we started this. So, sir, क्या आप कुछ कह रहे थे?
Where is Rishabh?
हाँ, ऋषभ बोला, तो ऋषभ का ये काफ़ी चीज़ें होती हैं, वेट कम हो जाता है, लॉजिस्टिक कॉस्ट कम हो जाती है, टाइम कम लगता है, ये क्या करते हैं।
What the selling is a value based. What is the value based? You reduce the material consumption, but you still deliver the same result. But he consumes what, 30% lower?
Yeah. So in bunker, like it's like 75% reduction. In
75%.
buildings, up to 75. In buildings, it's like 35%.
35%.
30 to 35%.
Let's imagine 35% of a large apartment building, right? How many crores they can save?
Please come, Ankita and Rishabh. थोड़ा सा डिस्ट्रीब्यूट है तो बेटर रहेगा. हाँ, थोड़ा सबको स्पेस मिले.
Yeah.
So sir, actually we were doing a PhD at IIT Gandhinagar.
Yeah.
So we were all there studying in 2016 onwards. She joined in 2014 and we joined in 16. And then I was doing my research on 3D concrete printing primarily, and then it is a multidisciplinary subject. It's not just civil engineering or like that. So like robotics was needed. We had to understand thermal insulation, thermal comfort of the building. So this is where we also an opportunity together, and we started MiCob in 2018 formally. But we were still doing research earlier than that. And then we started building smaller machines. So at IIT Gandhinagar we got some grants. So we built some smaller machines, tabletop printers. We developed some materials. That's the vibration unit that is there. Yeah, so generally vibration is to be done for declogging the material. So basically, we started like in 2018. So we worked on materials, robotics, software, and engineering products as well. Because that was a very new tech. Nobody knew how this actually is going to convert. And in 2017-18, things were still evolving. People were just doing research on 3D printing, how to integrate it with buildings. So it was also challenging for us actually to get some clients who can pay us. And there was also a large capital requirement. So yes, there was a large capital requirement to actually set up these kind of thing, and we were actually happy to have Karani at that point of time, who invested in MiCob and helped us actually to set up the things. And yeah, sir, मैं आपके बारे में बता रहा था. Yeah, so actually Karani sir actually was our first investor, and he had been great supporter since for past almost 3-4 years. He has been ensuring that we are working good. So we started by building our first small prototype, after which we got engaged with Karani sir. We actually had an even bigger machine which is under maintenance right now, that I think we were not able to showcase today. And then we started working with defense. So with defense we first worked. So we did like 3-4 months of R&D with them. We did multiple trials, we failed multiple times, and then we got success when we tested our products against tanks and rocket launchers. And at that point of time, after that, defense started to work with us, and we have delivered multiple bunkers. This year we will be delivering around 100 bunkers. We have delivered multiple buildings to them, 10+ buildings as well. And that was a good journey working with defense. And now the reason of working with defense was also that this is a new tech, and civil market does not accept things right away. Even though sir actually had built one guard room for him as our first product, but yeah, so otherwise in civil it's very difficult to get the acceptance without building codes and all. This is where defense actually helped a lot, and now people are willing to have, like we have orders with the Adani group as well and other clients as well. So this is now coming into the mainstream, and we look forward to scale it up faster with support of all the stakeholders in this industry as well.
So defense became your early customer.
Yes, right. Yeah.
Very interesting. Very untypical in
Generally.
So what is the biggest value you bring defense?
So imagine sir, they were making bunkers in 30 days.
30 days.
Using their own soldiers, like 10-15 soldiers. Now they are making bunkers in just 2 days. Using like 6 to 7 soldiers. They have reduced their logistic requirement. They were transporting 80 tons of material for making one bunker. Now they require only 20 tons to be transported. That is another big advantage for them. Plus it is blast resistant. I can show you the video where actually the bunkers that they were making using stone and other things were not able to actually take the hit. We have actually developed a product which is taking that blast resistance. So it's a combination of these things which actually is pushing them to buy.
Is that based on a material that you use?
So multiple things are there. So design is also there. The way these are linked, the way these are interlinking is done. The way we have actually distributed the load of the incoming impact or ballistic missile. The way we have designed the structure in that way. So those things are catering for that as well.
How do you test a product like this?
At site, sir.
At site?
Yeah.
And
So
they
otherwise
will
small testing we do here.
No, but they will actually blast it?
Yes. I can show you sir the video. Yeah.
Oh, I see.
They do the blast. Got it tested against Federal Tank of India. That is 290 feet.
The real blasting?
Yeah. Real blast. I'll just show you the video.
Wow. But these blasters are also changing based on their own adoption of technology,
Correct.
right? Because US will be supplying to all these Pakistani guys.
Yeah, so there are some multiple levels of threat and multiple levels of ammunition that have to be considered when designing these things.
Yeah.
So yeah, we have to take care of all those things in the design process.
Yes, that is how US makes money. US sells to Pakistan, US sells to India. They sell to both and they make money.
And then ask them to fight.
Ask them to fight so that they can resupply. Customer retention. Yeah. Interesting. Wow. So, other countries also would be interested?
Sir, they should be, but actually we would be restricted to supply to the countries which are like I would say
India friendly.
primarily.
Yeah.
For bunker.
But you can use the same design?
So yes, primarily yes. Like some people have also started to do this in Israel or Israel में Ukraine, sorry, Ukraine में. So in people, some were trying to do it in Ukraine. They have not tested yet. So in global level, I would say